Hi, this is Benoy Thanjan, your host of the Solar Maverick Podcast, and also the founder and CEO of Renew Energy. Renew Energy, we're a solar developer and consulting firm. We've developed more than 100 megawatts of solar projects across the US, and we help clients execute clean energy projects with confidence. We act as your owner's rep, overseeing developers, EPCs, and financing partners to de-risk your project and keep it on schedule. We also provide development as a service, supporting origination strategy and execution so you can advance projects without building a large internal team. On the renewable energy credit side, we offer REC brokerage, REC asset management, and custom renewable energy credit research, helping clients understand pricing, policy shifts, and long-term market dynamics. In addition, we provide new market analysis and financial modeling to evaluate opportunities, assess project viability, and support investment decisions. To learn more, reach out at info@renewenergy.com. That's info@reneuenergy.com. We'll also have information on the notes of the podcast as well. Let's get into it. Hi, this is Benoy, your host of the Solar Maverick Podcast. I wanted to invite our Mavericks to an event that we're having at Intersolar in San Diego coming up in February. We did a fundraiser last year and it was a great turnout in San Diego, and we're doing it again this year on Wednesday, February 18th from 5:30 to 8:30 right in downtown San Diego near the convention center. It's completely free to attend, and it's a great opportunity to connect with other people in the clean energy space. Big thank you to our partner and sponsor, Positive Deviancy, for supporting this year's event. If you'd like to join us, you'll find the event link in the podcast show notes. And if you're interested in sponsoring the event, you could reach out to us at info@reneuenergy.com. Look forward to seeing you in San Diego. Let's get into it.
So we can choose these well-scoped problems, get in the field, deploy a fleet of robots, do something good for the world, install a lot of solar, collect a lot of data, build that data, and then over time, the capabilities of the system can only grow. So we like to say that, today our equipment's the worst it's ever going to be. It's only going to get smarter and better.
Hello and welcome to the Solar Maverick Podcast, where solar meets entrepreneurship and experience. I'm your host, Benoy Thanjan, so let's get into it.
Hi, this is Benoy, your host of the Solar Maverick Podcast. I'm really excited on this episode to have James Emerick. He's a co-founder and CEO of Cosmic Robotics. I also have to thank Jade Garrett from Positive Deviancy from introducing me to James. And James is actually a listener of the podcast, and I'm blown away actually by the Cosmic Robotics technology. It's amazing to see these robots installing utility scale solar. James, thank you for making the time. I know it's a really busy time of the year, especially with incentives and trying to finish projects and continuous construction. So thank you, James, for making the time today.
Yeah, thank you. Great to be here. Yeah, long-time listener, so I'm excited that we're able to make this happen.
Yeah, definitely. And can you tell our audience, if they're not familiar, what is Cosmic Robotics?
Yeah, so Cosmic Robotics, fundamentally, we're a construction equipment company. So we build autonomous equipment, starting for utility scale solar. And the first product that we're building and developing right now actually installs PV modules onto the racking on utility scale solar farms. So it's an autonomous vehicle with an industrial arm on it that picks up solar panels and places them onto the racking for folks out in the field. And our goal is to make the most labor-intensive aspects of solar construction faster, safer, and more predictable.
Yeah, and it's also too like the construction's usually the aspect of the actual labor is usually the most expensive. So then you're obviously innovating and lowering the construction costs, and you don't have to worry if obviously it's a robot. People obviously get tired early, will can work a certain amount of hours. So that's amazing to hear about that innovation that you're.
Yeah, exactly. And module installation, it's not only the most intensive task in terms of like labor hours and the amount of work that it takes to get done, but also it has the highest number of OSHA recordable injuries of any task on site.
Oh my gosh.
Safety is number one, so that's actually the most critical piece there. And then on top of that, we can build a piece of equipment to get work done that much faster, all the better.
Yeah, definitely. How did you and your co-founder, start Cosmic Robotics? It'd be great to get to, I think also your background too explains the journey to where you are today as well. That would be helpful too for our audience.
Yeah, totally. Yeah, I mean, I've always been curious, like just how the world gets built, and I kind of view construction in general as the foundation of society, right? It's like what everything else is built on. I was always really curious about that. And growing up, my grandfather was a home builder and a building inspector, and so I spent a lot of time on his projects. And it's like just really exciting to see how the world gets built, and always kind of envisioned, how can we build faster, bigger, more ambitious projects. And what kind of became clear to me was that, there wasn't a lot of tech adoption for construction, years ago. Like the tech wasn't really ready yet. So I always wondered, how we can start to get newer tools into the field. So I studied mechanical engineering and robotics and found myself at a couple construction robotics companies, and then ended up starting Cosmic with Lewis, our co-founder and CTO. And his story, he comes at it from a totally different angle. So it is like childhood ambition, or his ambition from childhood has been to build a city on Mars, which sounds, crazy. And so, but he was doing it. So he went to Caltech. He built rockets at Relativity Space, like 3D printed orbital class rockets, spent some time at other top aerospace companies. And he realized that transportation was going to be a solved problem to get off of Earth, but figured, okay, when we get there, like where are all the construction robots that are going to build the infrastructure we need? He went looking and didn't find any, but he found me. And so together, we started to think about, okay, how can we make a really big difference today in how construction gets done, and what's the highest leverage task in construction that, moves society forward? And then from there, how do we build a technology platform that eventually goes beyond? And solar just makes a lot of sense, right? It's one of the fastest growing verticals in construction. That's the most economical, fastest new energy to deploy to the grid, and has just a huge labor bottleneck that can be solved by new technology today.
Yeah, definitely. That's a really great, sort of description of how you started the company, and obviously you and your co-founder's background and why you focused on solar today. Obviously, I know you have other uses in mind for the future, as you mentioned, like interplanetary construction with robotics. Can you also talk about to like our audience, like what are the like productivity gains on the field, and whether it be a percentage or, an X, a 2X, 5X compared to, obviously a standard like laborer or installer or a person putting in panels?
Yeah, totally. Yeah, so right now, just the module install task, right? Pick up panels, place them onto racking, and have a crew of anywhere from 4 to 7 people on site, plus telehandler, a skid steer, and an off-road forklift to carry the modules so folks aren't walking across the field. So they're 80 or 90 pound solar panels they're lifting overhead, placing hundreds of times on racking. The best crews today, I mean, people are pretty incredible. The best crews today have that like 4 to 6 or 7. They could install like 4 to 600 modules in a day. That's really fast.
That's a lot, and that's fast.
And people are incredible, right? And that's also what's made it so hard for robotics to enter construction, is like partly people are just that good. But our equipment today, we've designed it to be a drop-in replacement for that process. So you don't need any new hardware, new equipment. We work with all the major racking OEMs and module OEMs, and our piece of equipment just does the heavy lifting. So instead of 6 or 7 people plus a skid steer, you just have our piece of equipment with anywhere from a crew of like 2 to 3 people to do the operation of the robot, kind of just overseeing it, make sure everything is safe, and then do the fastening. And what we found actually is the robot kind of outpaces the fasteners. It just moves so quickly. And we're hitting right now targets of around like 500 modules per day, but with half that crew size. And then over the next year or two, we'll have developments where we get to about 2 to 3 times as fast as the best crews today, with a fraction of the labor support needed.
Yeah, that's amazing to hear. And, I have a question. Like, this is probably like a little bit off the topic, but I know I was listening to an interview that Elon Musk did about robotics and the Optimus robotics. And the challenge was that the hand is the hardest thing to replicate, like the human hand and like grabbing the panels. But I think grabbing things, but I think it's easier, right? Because you're using a panel, maybe using a forklift type structure, right? Based on what I've seen on the videos that you have, right? And then you have actually humans there as well, right? If there's any issue with is that correct?
Yeah, exactly. I think the like hard part with robotics in general is first sensing the environment around you, right?
Yeah.
Especially in construction sites, but manufacturing anywhere. These are dynamic environments. with a high safety threshold, and you need to be able to perceive the world around you in various lighting conditions, environmental conditions out on sites, right? We're handling these, glass and metallic reflective objects, various sunlight conditions, shade, rain, hail, sleet, snow, 100-degree heat. And so first of all, the sensing is really hard. And then after sensing for something like a humanoid, then the manipulation is the challenge, right? How do you actually pick up an object that's usually unknown? And, is it going to deform in your hand? Is it going to, fold? Or what are the physics of it when you don't know it? Our approach to robotics is, instead of trying to go after the holy grail of generally intelligent humanoids from day one, we view robotic capabilities as a gradient, right? We can start with like really well scoped problems like solar installation, where we know the geometry, we know the shape of the solar panel that we're picking up. So it's really easy to like make some assumptions about the world around us. And then we know the type of racking that we're installing also, so we can make some assumptions. So it makes that perception problem and manipulation problem a little bit easier because, we know what we're grabbing. And then over time, what our approach is that we get out into the field with these well-scoped problems. We can collect a lot of data because that's usually the bottleneck in robotics, is that we just don't have enough data from the real world to train these AI models to be able to reason about what's going on. So we can choose these well-scoped problems, get in the field, deploy a fleet of robots, do something good for the world, install a lot of solar, collect a lot of data, build that data flywheel that we typically call it, right? And then over time, the capabilities of the system can only grow. So we like to say that, today our equipment's the worst it's ever going to be. It's only going to get smarter and better. It starts with a niche task. And then over time, we can build towards something that is a little bit more generally intelligent for the field and start to take on other tasks first in solar construction. So instead of just doing the module installation, but start to look at how do we install the rails on trackers? How do we install bolts on fixed tilt? How do we start connecting the wires up on site? You can imagine we have this piece of equipment that has cameras and LiDAR and sensors on it. You can start to reason about the world around you and do some quality control and quality assurance on site as well, right? We have all these sensors. We might as well use them to say, hey, before we install modules, let's check that the rail height is right and that we're not going to have to remediate this, in a few days after doing the whole install, right? Once we install the module, we can get before and after photos. Was there a crack? Was it damaged? What was the force that we handled it with? And allows us to, build a more useful system over time. But we like to start with those really well-scoped problems and not try to build a generally intelligent humanoid from day one.
Yeah, that's actually really interesting. I mean, it makes so much sense. And obviously, you could correct me if I'm wrong, but like the easiest part of the installation that probably costs the most amount of money, you're focused on. And then obviously, as time goes on, the technology will get more advanced and you're able to do different parts of the installation process. How long do you think it'll take to do like some of these other things or even incorporate like AI and have enough data that you don't need a person to be controlling the robot?
Yeah, so that's the other beauty of kind of take a bit more of a grounded, stepwise approach, is you don't need a internet scale data, like these LLMs have, like sucking up all YouTube videos and, the entire corpus of the internet from day one. So in just deploying our small fleet of robots to projects last year, we have enough data where now we've trained some AI models on the specific hardware that we've seen on projects. Um, so we are starting to build the early stages of that, where we can start to reason about the environment a little bit more intelligently. And then over time, it only, that flywheel picks up, it only gets better. So I think it'll be a relatively short time, the order of months to a year or two before we start to see some of these applications come online really quickly.
Yeah, that's amazing to hear how fast your technology is advancing and that it could do obviously other stuff, as you mentioned, which is pretty amazing.
Yeah, I mean, one of our other kind of core approaches is, and the same thing that's actually made solar really great, is that it's highly modular, right? Same kind of core components, you can mix and match them to build a 5 megawatt project or a 500 megawatt project. That modularity and scalability is key. And we've designed our technology stack to look kind of similar, where the core hardware and software is modular so that we can mix and match it to the application. So different size machines, different applications, and that allows us to build the product portfolio really quickly.
Yeah, definitely. That's great to explain that. That's amazing to hear. What feedback are you getting from EPCs and construction crews that are using the robots?
Yeah, I mean, I think in general, like the whole industry is just trying to do more with less, right? There's never enough time on site. And so it's been really surprising, actually. Having been in the field for a little while, there was 5 to 7 years ago, a little bit of an educational piece around construction robotics and how they can help crews in the field. But when we started Cosmic 2 years ago, I think folks at that point kind of got it. We had the chat GPT moment where people realized, hey, AI systems in general are going to be very useful for humanity. And so it's really easy for us to get in a room and folks understand like this is the future and they want it. And our approach is to build a useful piece of equipment that works with crews, not in spite of them, and then, helps them get their work done safer. So the reception's been really great. We've been really excited. At this point, we're just capacity constrained. We can't build robots fast enough to get them into our customers' hands.
Yeah, I guess that must be a very custom process, right? Because you've only had Cosmic Robotics for 2 years, and so it's not like an assembly line, right? That you could quickly, especially now, right, with the big beautiful bill, everyone's like trying to get the full ITC and qualifying for continuous construction. Yeah, how do you deal with that issue and the time frame?
Yeah, it's crazy. I mean, we built a small handful of what we'd call like more prototype and development units that we got into the field in our customers' hands last year on a variety of different environments. Our approach was, along those data lines, like, hey, let's see a lot of projects. Let's work with a lot of different crews. Let's make sure we're building the right thing. And we had a few customers that wanted to purchase the equipment already, our development prototypes. And like, we're developing a new vehicle that's going to come out later this year. That's our full commercial unit. So we're standing up a small manufacturing line here in San Francisco. That'll start cranking those out at the end of this year. And so, yeah, we just can't build them fast enough. Everyone is lovingly handmade here in San Francisco right now. And yeah, we'll start to build a bit of a fleet over the next couple of years.
Yeah, that definitely takes time. That's really, interesting to hear. Can you provide like how many megawatts of construction that the robots have been involved with to date?
Yeah. Yeah, to date, it's only been like probably around 10 megawatts. They're relatively small projects. Our approach has been with our development units that go see all the different environments and collect that training data. And then by this year we'll drastically increase that and start to build the fleet.
Yeah, definitely. And then does it have to be in a certain weather environment for the robots to work optimally? Like obviously like you have like the nor'easters and in the Northeast, obviously a lot colder weather, snow, and then other parts of the country where it's extremely hot or desert like. Does weather conditions for the install impact the robots or no?
Yeah, we designed the equipment to be, able to handle anything the elements throw at it, right? If we can't install in the desert or in, Acadia National Park, then, it's not useful for the field. So we make sure that it can span that whole operating range. And then typically, the shorthand that we use is any time that it would be safe for a human crew and craft workforce to be out there working, the robot can work. And so generally that's the approach we take. Although I will say we have operated in one of the big weather conditions is actually wind, right? If you're picking up these 2 meter by 1 meter solar panels, it's like a sail in the wind. And so wind speed is usually what shuts down a lot of projects due to safety concerns of modules getting picked up and flying around. And on one project, we experimented with operating outside the range that it would normally be comfortable for a human crew to do that. But since we have this industrial piece of equipment with suction cup grippers to get a really good hold on the module, and we can have people far away in case anything happens, we kind of push that envelope a little bit and we were able to operate a little bit outside the normal envelope, right? And that just helps decrease project timelines. And over time, if we can expand that a little bit more, you can start to project out timelines with a little bit more certainty, which is the thing that we all want in construction.
Oh, for sure. As you know, the more certainty, the better it is for everyone and all parties involved. You kind of actually mentioned this a little bit. Like, what does scaling look like? You talked a little bit about it. Obviously, there's going to be a lot more megawatts in the future, incorporating AI, doing other things other than, just installing the panels. Can you talk about that? Like, what's scaling?
Yeah, yeah. From our grounded approaches, hey, let's get out and let's install, tens and hundreds of megawatts, gigawatts of modules on site, and we'll build the fleet to do that. And then there are a lot of adjacent tasks around module install that are perfect for our equipment to also start to tackle on things like fastening, rail install, more around trackers, the QA/QC component. And I think what we've seen in our early days, we're only a seed stage company, so we're pretty early, but it's purely limited by the capacity for us to build robots and get them out there. And our customers are really excited about the potential for this technology.
Yeah, definitely. It's really exciting. I guess, what are the biggest barriers to adoption today? It sounds like you have a problem of not having enough robots for the amount of projects, potentially.
Yeah, it's pretty interesting. So the barriers on our end are, hey, we just need to get more systems out there and make sure that they're doing what we say they're going to do. But I think it's interesting to think about, like, what does the world look like when we do start scaling and there are more of these robots? And there are folks that are tackling the problem in the same and different ways. And so I think we'll see, more technology like this out in the field. And our approach to date's been, hey, let's make a drop-in replacement for how things are done today. So same crew mix, maybe a few less people, or that same crew, can be augmented with robots to get even more work done. The same tracker hardware, the same modules, the same kind of site process. But over time, you can start to think about, as that scale starts to hit, and this is a proven tool, that we can also have a little bit more certainty around, starting to plan site operations around the use of robotics. And that might include key parameters like, tracker heights, row widths, GCRs, how you lay out the project, where do you place the module, the pallets, and how do you shake things out in the field, and start to rethink, where do humans play a role in solar, and where can we use new equipment to actually accelerate that? And so we're a little bit early for that, but we're starting to see some signs where folks are starting to rethink the entire construction process a little bit based around new tools of ours and others that are coming down the pipe here in the next couple of years.
Yeah, definitely. I appreciate you explaining that is key. And I feel like with declining incentives relating to solar, people are looking for creative ways to lower construction costs. And obviously, your product is a great way for them to do that.
Yeah, exactly. I think you can start with certainty. So you can have fewer surprises in the schedule, maybe tighter bids. Then if you can have a little bit more labor efficiency, that's a little bit more economical. But then on the flip side of things, you have crazy data center investment and AI build out that's happening. And the key limiter there is just speed to power in order to get GPUs online. And so there are a lot of really large data center builders now that are realizing that they can't rely on the grid to get grid connections to actually to get their data centers online. And similarly, there's a backlog for natural gas turbine generators and all the other power infrastructure. And solar, I think, is going to play a really big role in behind the meter, co-located with data centers to actually fuel the AI build out. And so on those projects, cost is a little bit less of a concern, and it's just all about speed to power.
That's a great point. I appreciate you explaining that. And I think it's like a huge opportunity, behind the meter power, and especially with solar power and using Cosmic Robotics for that. I know you mentioned like companies were buying the prototypes. Do you also have like a lease option, or is it just a purchase option when it comes to?
Yeah. I think we work with our customers on whatever economics they need to see and how they like to use equipment. Some folks are really proud of their equipment fleet and equipment heritage and their mechanics, and they like to own large fleets, and we're happy to sell equipment as CapEx. Other folks, prefer to lease, and so we have lease to buy options and finance partners that, we can arrange for that. From our point of view, even though we make robotics and autonomy pieces of equipment, at the end of the day, we are a technology provider and an original equipment manufacturer. And so our business is building the technology and then selling it to our customers. So the folks that are actually on the ground building, and however we get those tools in their hands, we'll work with them to do that.
Yeah, definitely. That's great to know. And obviously, yeah, everyone has their, financing options on, how they want to, I guess, invest in the equipment. You mentioned this a little bit too, beyond solar. Like, can you talk about like what other sectors are perfect fit for your technology?
Yeah, what makes solar great as a starting point for, well-scoped, high ROI construction robotics tasks is that it's really modular, right? So it's standardized components done very repeatedly at scale across and they use the same process across EPCs and customers and across the whole industry. And so that's the lens that we take when we look at other tasks that our technology is really a good fit for. So at the core, what we're building is mobile manipulation, as a roboticist would call it. So being able to drive around an unstructured environment like a construction site and then pick something up that you know what it is and place it in some other known location. And so knowing what those objects are and then knowing where to place it's really the hard part, right? And so other verticals in construction that are pretty standardized and modular are kind of the next steps. So the obvious one, since they're co-located with each other, are data centers, where you have the same racks of GPUs and electrical hookups and high voltage wires run, through acres large buildings. And so that's a really nice adjacent market that we're starting to build into now, building off the core platform that we started with solar.
Yeah, I think it's a huge opportunity. Obviously everyone's talking about data centers and there not being enough data centers to power obviously the AI revolution that's happening, and obviously your technology to make things a lot more efficient and quicker to do. So that's exciting to hear. I mean, does it make you nervous as an entrepreneur, like to think about like doing an assembly line sort of versus that's a different sort of scale? But I wonder whether too that makes you curious as well, like to create something at scale in an assembly line format. Looks like that would be the future and mostly being created by other robotics and obviously Henry Ford and obviously, yeah, to me it's interesting, like it's how complicated it could be to try to
Yeah, for sure.
scale and keep the quality. And
Yeah, eventually we'll have the factory robots that are building the construction robots and then sending them along their way. And we can sit back in our chairs and direct them on what to do and make sure they're building the right things. I think for us, compared to automotive, scale is still a relatively cute and small number. And right, we're talking about dozens, then hundreds, then thousands, whereas automotive's in the millions and tens of millions. So I think they're different paradigms to scale. And so for us, not a huge leap to go from single digits where we are today to start to build out the proto lines to get these things in the field.
yeah, definitely that's a great point. And then as far as like the prototype, I mean, how many prototypes now have you had since you initially created the first prototype to now? And how much more advanced is I can't even imagine.
Yeah, we've gone through around 3 or 4 major hardware revisions in the last couple of years
Yeah.
and built a handful of systems around them, built some new systems, upgraded old ones. Yeah, generally the state of hardware and robotics and AI these days is that there are some really great off-the-shelf sensors that we can use, like cameras and LiDAR that are pretty low cost now. So that allows us to iterate really fast, really quickly. And it's almost like, hardware engineering at the pace of software engineering, which is typically a lot faster, obviously.
Yeah, definitely. That is really interesting. It's interesting. I learned a lot about LiDAR through Waymo because obviously they're using LiDAR technology for self-driving, and then Tesla's using the data that they have from their cameras. What is the best way? Like, it sounds like you're using a combination, right, of both technologies to ensure the optimal installation experience. Is that correct? Or
Yeah, that's right. Yeah, LiDAR is really good for really structured like sensor reading.
sure.
So things where like we know the shape of an object, like a solar panel and like a torque tube. And then the cameras are really good to kind of fill in the gaps with the different colors and textures and variability that you'd see in different lighting conditions and things like that. So we fuse them both together to make sure that we get really reliable and precise position and orientation measurements of whatever object that we're picking up. So that's the other thing is, we're picking up these known objects, but at the end of the day, it's a kind of a floppy piece of glass, and they need to be handled relatively delicately. So we can't crush them. You need to know that you're picking it up in the right location to be able to install it onto the torque tube and to have the holes aligned. You need close to millimeter precision, which is a really hard task in the outside conditions. So we need to take all the sensor modalities possible, make sure that we're handling the units with care and then placing them exactly where we want them to be.
Oh, that's interesting. I really appreciate you explaining that. I forgot about those sort of complexities that are involved in the installation.
Yeah, I mean, we use the same technology, the suction cups and the gripper, and even the 6 degree of freedom industrial robot arms that all module manufacturers use in their factories to handle and pack modules. The confounding factor for us that makes it that much more complex is that we're not doing it in the four walls and the roof of a factory. It's out in the field, and that makes it that much more challenging.
Sure. That is so interesting. I didn't even think about the external climate versus internal. Obviously, there's more variability because you're external. So I appreciate you explaining. That's really interesting. The Solar Maverick podcast is about solar and entrepreneurship. What advice would you give to clean energy entrepreneurs? It sounds like before you started Cosmic Robotics, you might have had a prototype and then was marketing potentially to customers or investors. And obviously, you've raised the seed round. And I think you come from a background of entrepreneurship as well. I think your dad was an entrepreneur, right?
Yeah, I have a family of various entrepreneurial pursuits.
Yes. Like, can you talk about? I know that I asked you like 6 questions in one, but it would be great to get your perspective. I mean, it's really interesting to hear what you're doing and what too gives you the confidence. I mean, this is something that you and your co-founder saw that no one was doing, and there's a huge ROI if you focus on the solar panel installation, if you could come up with a successful prototype.
Yeah. Yeah, there's a lot there. I think, fundamentally it's, you got to get out in the field. So I had the great privilege and an amazing childhood that I was able to, see construction for a long time and kind of be around that. But then more specifically in solar and clean energy and in the space that we play in with Cosmic, I think like get in the field, talk to customers, talk to, any executive you can get in the folks doing the installs, go up and down the value chain to, folks that finance projects, developers, EPCs, subcontractors, module manufacturers and track manufacturers, get in as many rooms and more importantly, fields as you can to just make sure you understand everything that's going on and can like form that worldview. And then from that, usually there's some consensus that starts to arrive and you can start to see where the patterns are. So yeah, I had a little bit of a background in construction. In a previous professional life, I also spent a lot of time on solar farms doing other robotics tasks. And so got to see firsthand just the challenges in solar construction and where new tools might be a good fit. And then when we started Cosmic, we did a bit of a roadshow, kind of traveling across the country, talked to everyone that we could. And so that helped to give us the conviction that, we're onto the right thing. And then at some point, you need to get into the shop and just build something and, make sure that we're onto the right track there. And I think the one other thing that we deeply believe that I think is obvious to us, but maybe non-obvious to some, is that we have like a really deep respect for anyone that's out there doing this work in the field and 100-degree heat in the winter and the cold. Like it is hard work that not everyone can do. And we deeply respect the folks that do it, and we want to make their lives a little bit better and easier. And so that kind of flows through how we think about the products we build, how folks interact with it, and how we interact with customers on projects.
Yeah, I mean, that's explaining those 4 or 5 questions in a very concise manner. I appreciate it. And then just in general, like what advice would you give to like clean energy entrepreneurs or who want to start their own business, even maybe advice on fundraising? It was interesting because you talked about how you guys came up with the concept and first went out to talk to as many people as you can. Then it sounds like you're like, hey, let's like actually do this. And you started Cosmic Robotics, I think you said 2 years ago. So
Yeah, let's see. There's so many other avenues that
I'm
we
sure
can
there's
take
so
it.
many. Like for me, just listening to what you say, both of you saw an opportunity of what you're both passionate about and what is the easiest and highest value that you could actually, and then your passion to, you could hear the passion that you have for solar by talking to, and specifically like the construction related process. So to me, like that, like the passion, and then you saw a need, and then both of your expertise in robotics is pretty like, and obviously persistence, right? I'm sure there are so many roadblocks that I can't even imagine because this is pretty complicated stuff.
Yeah. Anything that you do in life like is probably really hard. So you might as well choose something that's like you're the most passionate about. You can have the most fun and is like what we think about is like the highest leverage use of our time, right? Like we don't have a lot of time on this planet, unfortunately. And you might as well try to maximize the fun and impact that you can have. And that just makes it so much easier when it inevitably gets really hard, to kind of push through those days. And if you love what you do and, you see an impact, that's, I think, really, really helps. And yeah, the game we're playing, right, is decades long vision. And so I think like it's really hard sometimes to balance, where we want the world to go and where we see it and that like really exciting, inspiring future. And then like day to day, you kind of just need to have that in sight, but then put your head down and get to work and kind of trust the process that once, how do you eat the elephant? It's just one bite at a time, and that you'll get there.
Yeah, that is great advice. I appreciate you giving that advice, James. And the other thing is what's the best way for our audience to learn more about Cosmic Robotics or you?
Yeah, I think the best way, there's a little bit more on our website, cosmicrobotics.com. And then we're relatively active on LinkedIn. You can find some other pieces of content and some cool videos there.
Yeah, definitely. We'll have that on the notes of the podcast. Also, too, I wanted to ask, who are the ideal people that you would love to connect with from our listeners?
Yeah, I mean, we just love getting out in the field with the folks doing the work. A lot of our customers are engineering, government construction firms. The EPC is actually doing the work. So yeah, from the craft professionals to the soups on site up to the project executives, those are the folks that we like spending the most time with.
Yeah, definitely. This has been an amazing interview. I appreciate you making the time, James. I learned a lot, and thank you for sharing.
Yeah, likewise. This was a blast.
Yeah, it was a blast. Thank you.
Thanks, Benoy.
Thanks for listening to the Solar Maverick Podcast. The Solar Maverick Podcast is brought to you by Renew Energy. We're a solar development and consulting firm. If you believe that this podcast is adding value to you, please give us a 5-star review and share with those that you think could benefit from this information. Please email all questions, suggestions, and feedback to info@renewenergy.com. That's info@reneuenergy.com. The Solar Maverick Podcast is produced by Podcast Laundry and executive produced by Benoy Thanjan and Kevin Y. Brown.